Hello guys, today we are going to see about ice formation. That is, we are in an Antarctic lake and the temperature outside is lesser than 0 degrees. Like T is a positive constant, minus 5 degrees or minus 10 degrees or minus 3 degrees, some degrees Celsius. And the water here is at 0 degrees Celsius and there is some amount of ice here. Because after 0 degrees Celsius, it will start freezing. So water has to be in 0 degrees Celsius. And here we have ice formed. Now, what we are going to see is what is the time required to form a specific length or length, a specific thickness of ice cap. So first, what do we know? What are the prerequisite information we have to know is heat flow through the ice. Let us take at any interval, any specific time. Let's suppose already X amount of or X thickness of ice has already been formed, and at time interval dt, dx is formed. Dx amount of ice, extra dx amount of ice is formed. Now, what we know is through this amount of ice, the heat transfer will be dq by dt. This is heat current. Heat current will be equal to K, conductivity of ice, A, area of this ice cap or this lake by X. X is the thickness, theta, or theta will be the temperature difference. In this case, what will be theta? Theta will be the constant T. You may have a difficulty or a problem in minus T or plus T. We are taking the direction of heat, like heat is going to go from ice to the external environment, from water to the external environment. We are cooling water. So the heat flow will be from water to the outside. And this in normal circumstances, how do we do? We have a box, we have 100 degrees Celsius, we have 30 degrees Celsius. We do KAYL is equal to 100 minus 30 now. This is in the direction of lesser temperature. Similarly, 0 minus T. That is giving us just T. Okay, I'll erase this. This is not, this is just for understanding. Now, let us suppose dq amount of heat is flowing. And what will this do to the water? If L is the latent heat of fusion, then dm, small amount of water is formed into ice now. So to form ice, this will be the amount of heat given away by water. Now we are going to equate dq from here and here to find the time required for forming whatever x thickness of ice. Let us go on with the question now. Now, first, this I can write it as dq by dt. This will be equal to Ka by x into t. Now, dq can be written as K by xt into dt. Here T is temperature, capital T is capital T is temperature, small t is time. Please don't get confused. Now from this equation and this equation, I am going to write another equation. And what is that equation? KAT by x into dt is equal to dm into L. Now for the small mass m, can I write it as area into dx? This gives us the volume into rho, where rho is the density of water. Okay. Now this can be written as KAT by x dt is equal to A rho L dx. Now when I take dt in this side and take it all the other stuff on down that side, first I can cancel out A and A. We will get rho L by kt into x dx. When you integrate this on both sides, time is equal to rho L by 2 kT into x square. If you want, this is the time required for forming ice from scratch, like without, there is no ice, but you want to form ice of thickness x. Now, what if already there is x and you want x naught? Let's suppose from x naught to x1. Now, what will be the time is? Time will be equal to, you just have to put limits to this integration. That is rho L by 2 kT into x1 square minus x naught square. That is time for forming this from scratch and time for from forming this from the second one from scratch. So this is our formula and this is our derivation. Hope you like this video. Please give a thumbs up if you like this video and understood it.